Okay, so let's look at a couple more LCD problems. These are going to be problems involving variables. All right, so suppose that we have the fractions 4 over 5x squared and 1 over 10x cubed. Okay, so we want to find the LCD of these two denominators. Note, it's the least common denominator. The numerator doesn't matter, right? So we're just looking at the denominators here. So I write down this denominator fully factored, all right? So when I write it down, 5x squared, I can factor 5. Well, 5 is a prime number. It's already fully factored down as far as it goes, so nothing to do there. X squared, what I'm going to do is write this as x times x, okay? Okay, so that's 5x squared. Now let's go to 10x cubed. All right, so 10x cubed. And we're going to write this out. Now, 10 can be factored down. It can be written as 2 times 5, right? So that one can be factored. And then x cubed, I'm going to write x times x times x. Okay, so this is the factorization of 10x cubed. Now what I'm going to do is the same thing we did with the numerical examples in the other video. I'm going to look at the different factors I have. I have 2, 5, and x. Right? And I'm going to find out the most number of times that a given factor appears in these expressions. So let's start with 2. It appears once here and no times here, right? So 2 appears at most once, and so I include it one time in my LCD. So my LCD is going to have 1, 2 in it. Then I go to 5. 5 appears at most once here and once here, so it appears at most once. So there's a 5, a single 5, because it appeared at most once in any given factorization. Now x appears 3 times here and 2 times here. What was the most number of times it appeared? 3 times. So I'm going to include 3 x's. So my LCD, if I multiply this out, what do I get? I get 2 times 5 is 10, x times x is x cubed. My LCD is just 10x cubed. It happens to be the same thing as this denominator here. Sometimes that happens. Okay? Let's do another one. Let's do one with some polynomials, some more interesting polynomials. So we'll do this. 3 over x squared minus x minus 6, and then negative 1 over x plus 4x plus 4. Okay, so here's my two fractions. I want to find the LCD. So I'm going to take each denominator and factor it down, all right? So let's take x squared minus x minus 6. Well, think about what you know about how to factor, and you should be able to figure out that this is x minus 3 times x plus 2. Okay, now let's look at this other one over here. Oops, I forgot to write a square here. Let me insert that. That should be an x squared plus 4x plus 4. So let's write that down, x squared plus 4x plus 4. I'm going to factor that one down. You should recognize that this is actually a perfect square, if you remember your formulas for factorizations. This is a perfect square, so I know it's just x plus 2 squared. I'm going to write x plus 2 times x plus 2. Another way to write x plus 2 squared. Okay, so now I see what my factors are. I've got a factor x plus 2, here, here, and here, and I've got a factor x minus 3. There's only 2 factors to worry about. What I'm going to do is, for my LCD, I'm going to count how many times does each factor appear. Well, in this factorization, x plus 2 appeared twice. In this factorization, it appeared once. What was the most number of times it appeared? Twice. So I'm going to write it down twice. Alternatively, I could have written x plus 2 squared. Right. Now I go to my other factor, x minus 3. How many times did it appear here? None, no times. How many times did it appear here? Once. What was the most it appeared? 1 time. So I'm going to write down x minus 3 once. So this is my LCD.